At this point in chemistry, we all know what happens when you pour acid over a metal. For most metals, that makes bubbles. For example, I have zinc and hydrochloric acid here, and I see bubbles. What are those bubbles? They're hydrogen. Zinc and hydrochloric acid react to form zinc chloride and hydrogen gas. Bubbles. Some metals don't react with acids to make hydrogen gas. The money metals don't, for sure. Gold, silver, copper. But most do. In your last chemistry class, you learned that these reactions are called reduction-oxidation reactions, redox for short. And you may have learned a mnemonic. Leo the lion goes grrr. Or maybe you learned oil rig. Whether you learned Leo, grrr stands for lose electrons oxidized, gain electrons reduced, or oil rig, oxidation is losing, reduction is gain. Losing and gaining what? Electrons. Either way, you learn that oxidation is losing electrons, so going up in oxidation number, and reduction is gaining electrons, so going down in oxidation number. We know that electrons are not particles. Electrons have a wave-particle duality. We can't quite figure out and understand what that is. But in this context, we are treating electrons as particles that can be transferred. For some reactions, electrons are transferred spontaneously and electrochemical potential is lowered. This is the direction the universe is headed. This can happen, for example, when a zinc strip is put in a copper-2 solution. We see evidence of change. We see the blue copper-2 solution getting lighter, and on the surface of the zinc metal, there is a precipitate. If we separate those two half reactions and have an external circuit, the electrons being transferred can do useful work. And because this is spontaneous, that is a voltaic cell or a galvanic cell. Alessandro Giuseppe Antonio Anastasia Volta was a physicist and a chemist who lived from 1745 to 1827, and he is credited with discovering or creating the first electric battery. Luigi Galvani, who lived from 1737 to 1798, was a physician, biologist, and a philosopher who studied animal electricity and used electric current to make dead frogs' legs jump. A voltaic cell is a galvanic cell. These names honor both scientists. These are spontaneous reactions that cause electrons to travel through an external circuit, resulting in useful work, like turning your flashlight on. When these electrochemical reactions are separated into two half cells, so that the electrons must flow through an external circuit, we call those batteries. And when the reaction comes to completion and equilibrium is reached, the battery is dead. In this chapter, we learn how to recognize redox reactions, how to balance redox reactions, how to predict the direction of spontaneous change, and how to do some calculations. And in lab, we'll see bubbles.